Welcome back to our series exploring extended fading and slow colour changing in digital lighting applications. In this video, we're exploring the intricacies of that digital resolution, particularly in the context of 8-bit control of LEDs, where a single DMX channel with 256 levels of intensity represents a single colour, and explain the problems it can cause for extended fade times and slow colour changing. We'll also touch on 16-bit control, which uses 2 channels of control per colour, but for now, we're concentrating on the limitations of 8-bit resolution, particularly in applications that require prolonged fade times. Imagine in a theatrical lighting application, at the conclusion of a dramatically low-lit scene, LED lighting is required to dim from 20% white to 0% off over a 60-second duration. Consider that DMX 512 control is being used in the most common configuration, which is 8-bit data. This would mean the LEDs are fading from DMX value 51 down to 0 over 60 seconds. There are 51 total changes during the fade, meaning that the LEDs are only changing their intensity at a rate of 0.85 times per second. Note that this is independent of the overall frame rate of your system, which you may be used to thinking about. Given how slowly these values are changing, viewers often describe the effect as steppy, as the light appears to reduce intensity in visible steps rather than smoothly fading. You can see clearly in this graphic that the 8-bit data to fade over an extended duration results in noticeable steps resembling a staircase rather than the desirable smooth ramp. The key concept to understand here is that digital communication protocols like DMX 512 use discrete numbers. Therefore, when working with a digital control lighting system, you're effectively working with specific whole number values. Even if your lighting control source's interface appears to allow fading from 20% to 19.9%, the actual DMX values being streamed on the output will map only to DMX intensity value 51, due to the finite number of intensity levels available. Therefore, while your system may attempt a smooth fade, the actual DMX values step down in rounded intensity levels, a process known as quantization. While this is normally unrecognisable and therefore acceptable for faster fades, it's often very noticeable and unsuitable for extended fade times. This concept is similar to, but independent of, what you might already know is the frame rate of the lighting source system. For example, say your lighting source is sending DMX frames at 40 frames per second. If it changed the value of a given channel in every frame, you would see an effective frame rate of 40 frames per second. However, if it can't change the value of the given channel in every frame because the lighting effect is transitioning slowly and due to the quantization described earlier, then the duplicate frames are meaningless for the given channel of concern. In this case, the 40 frame per second rate is really an upper limit to the maximum effective frame rate. However, the effective frame rate can be much lower, like in our earlier example where the effective frame rate is less than once per second. Next, we'll introduce another concept that can amplify the effects of quantization and make the steps appear even more obvious before we explain how you can fix this problem in your projects. Related videos on this important topic are coming up next. If you found this video helpful, don't forget to like and subscribe for more expert tips.